How's it going, guys? It's Jiggy here, and in this video we're going to be taking a look into the basics of the functional programming paradigm. We'll be taking a look at some of the problems that the programming languages we know aren't so great at solving, and why the functional programming paradigm is an answer to them. So let's crack on. First of all, what is a paradigm? A paradigm is basically a method of how you structure your code. Different paradigms suit different requirements, so in some cases it may be better to adopt a procedural approach over an object-oriented one. Some languages such as Python allow you to write in different paradigms, which of course is always useful. These two paradigms are useful and advantageous in many ways, such as having the ability to reuse code, encapsulate code, and provide a modular structure, for example. But what happens when we have a situation where the above advantages don't apply? What if we wanted to analyze big data? Oh, and by the way, check the link in the description for a link to our video on big data. In the case of big data, we wouldn't be too concerned with things like encapsulation, inheritance, and the like. We're more concerned with just getting from A to B as fast as possible, since analysing massive datasets can take a long time, as you can imagine. Essentially, we want to be able to input some data and output some data in the fastest manner possible. And this is where functional programming comes into play. So let's talk a bit about some features of functional programming that make it useful for crunching all this data. First of all, it offers the ability to abstract a function into a series of steps. This means that a large function, such as operating a car to drive from home to school, can be broken down into a series of functions. So, putting the car into gear is one function, taking off the handbrake is another, and so on and so forth. So by abstracting an overall function in this manner, it leads to fewer errors during implementation of your code, since things are made more granular. This feature means that you can identify issues much more quickly. As functions are run, it eventually snowballs into the overall function. Another feature of functional programming is that any piece of data can have any function applied to it. This means that any function can be used on any variable in the program. Unlike procedural programs, there's no inheritance, so this feature is made possible in functional programming. What you will find in functional programming is that there are no concurrency issues. This means that function 2 cannot take in the same variable that function 1 is using, only until function 1 is finished with it. Great, we're done. So let's have a recap. Functional programming aims to get from A, which is the input, to B as fast as possible. Functions are broken down into a series of steps. And finally, the features of functional programming, such as the ability to apply functions across any level of data abstraction and no concurrency issues.